we are going to present two topics. First is the baby bottle brush. The second is the car door trim cutting machine. And together with me is Dr. Yip Mum Wai. Okay, he's over there. And Mr. Keong. And I'm Foo Soon. So let's start our part 1, baby bottle brush. This is actually a true story which happened in Mr. MyTRIZ family. So let the show begin.
Ladies and gentlemen, do you have this problem, especially parents out here, moms and dad, you have baby and it's so difficult to clean the baby bottle. As a mother myself, I find that I have this problem. You see, no matter how I clean the baby bottle, I just cannot clean the dirt, especially at the edge, at the bottom of the baby bottle. It's so difficult. Darling! Darling!
Yes, darling, what can I do for you?
Darling, look at this brush. It is not working. No matter how I brush the baby bottle, the dirt just can't be removed.
You mean the bottom part?
Yes.
Oh, really?
How are we going to feed our baby daughter with this? It's so dirty. Darling, isn't it you a cheese master?
When I become MyTRIZ master then?
You help me to solve this problem.
Not easy to be MyTRIZ master actually. Oh, I'm thinking how to solve it. Alright, it's a big problem for my wife. And then, if I don't solve it tonight I cannot sleep with her, you know. So what do you do now? I think I have to think about it. Let me refer to the MyTRIZ book I got it 2 days ago. Yeah, alright. So, according to the MyTRIZ book, it mentioned that if a many type of products in the world is an indicator that it's the third stage of the S-curve. Alright, if a third stage of the S-curve, what are we going to do? They have a recommendations. So what is the recommendation? We add function. V equal to F over C. V is a value, F is a function, C is a cause. So we increase the function. And secondly, we can improve the design of the bottle brush. Now, how to improve the design? How to increase the function? It's not easy actually. How to do it? Let me think about it.
In order for my father to find the solution, he have to take off the problem statement first. And then he'll continue with the function analysis to analyze what is the function. After that, we'll follow by the cause and effect chain analysis to find out the root cause. After that, he will use several tools such as engineering contradiction, feature transfer, function-oriented search, trends of engineering system evolution, as well as 9 windows to figure out the solution. Poor father, his hair is starting to turn white.
It's really white. Okay, now we look at the function analysis. Now, this is the brush. The hand actually is hold the handle. So, or move the handle. So the handle or move or hold the body. The body is here. And then the body actually move or hold the blister. So this is the blister part. And the blister actually is to remove the dirt. Alright? And then the bottle is actually hold the dirt as well. So it's excessive. So in this case, it's our function analysis. Okay, then what is the root cause? Okay, I think I have to use the cause and effect chain analysis, CEC. I think I have to ask my wife. Hey darling, come again.
Yes, honey.
Oh, okay. Darling, can you tell me what is the problem again?
Darling, don't you listen to me?
Okay.
I say that this brush cannot clean effectively.
Oh, cannot clean effectively.
Yeah.
Why?
Because
and
the
what
force,
cause?
the force is not enough.
Oh, why and what cause?
Don't you see the holder is so soft?
Why and what cause?
The holder is made of twisted wire.
Why and what cause?
Well, darling, to reach the bottom of the bottle.
Really? Why and what cause?
To increase flexibility. Darling, why you ask me so many questions?
Oh, sorry. I think this is my job actually anyway. So, to increase the flexibility is a root cause of this problem. So, let me form a engineering contradiction, EC. So, if then but. If the flexibility of the body of the brush is high, not enough force, then the blister can reach a curved profile of the bottle. But the problem here is the dirt remover is not easy and incomplete. So the variables and the parameters are, the manipulating variable is a soft body, responding variable is ability to reach the deep curve profile, and the dirt remover. Improving parameter is adaptability, worsening parameter is a quantity or substance. So we refer to the TRIZ, both and correlation matrix. Suggested inventive principle are local quality, dynamization, and as well as a parameter change. So in the local quality, we make our body become rigid. It's a rigid body and flexible blister. That means it's controllable. And dynamization, also the same, soft blister with a rigid body, and the parameter change, we can change to the two different parts. This is our suggestion for this. Then, what is next? What is the rigid body? How they make off? My stomach ache. I've been eating so many meals for these few days. Alright, I have to do something then. Done. It's very hot. Alright. Oh, I found it. It's a feature transfer. This brush is actually carry a very good brushing force, and then it's an alternating system, and the base system here is bottom brush. Yes, the plus one add together, so I can get it, the feature transfer. But problem here is, how is the mechanism? What is the function? Yeah, FOS. Function, factory outlet sales. No. It's a function-oriented search. Yes, up to 500 function-oriented search. What is the parameter then I'm looking for? Body is able to turn at least 90 degrees, maybe less. Body have a high tensile strength to survive the pressure force from the handle. How to do it? Let me think about it.
Okay, meanwhile, my mom is at the hall watching TV. So this is a operation video that my mom loves to watch.
Crazy. Don't disturb, I'm thinking your solution.
What is that?
Operation so easy
No, darling, I'm referring to the tube they are using.
Laparoscopy.
Oh, laparoscopy.
Laparoscopy? Yeah, laparoscopy is actually what I want, whereby the video is hang, doesn't matter. The problem is the laparoscopy is actually very flexible, and then they can go inside the blister, then they can adjust. Have you seen any operation before? Okay, so with my laparoscopy and also my brush, toilet brush with a base system, normal brush, then I can come up with the idea with this. Even though it's a big one, but actually I can make it minor or small one. So laparoscopy concept is like this. You can see? It's a flexible. So they have to clean the curved part. I just do this. When I want to go inside, I just pop inside, and then I just turn, then I can clean the bottom surface of the curve. Thank you very much for the FOS. Darling, this one for you. Sorry, it's too big.
Wow, darling, this is so awesome. I can insert the brush inside,
I can see it tonight.
And then if I want to clean the inner bottom and the side, I can just bend it around and wash it. It's so clean and easy to use.
Oh, really?
Thank you, darling.
I haven't finished yet, go away. So this is a trend and entry system evolution. I'm also doing that because by using the trend of really dynamicity, okay, so I can call my brush an adaptable and flexible brush, and this is the monolith to elastic. Normal one, now is our new one, whereby it's adjustable. Alright. Not only that, the last one will be a 9-window diagram. Look at the 9 window. We have divided into the super system, subsystem, and system. So this is our existing one, and there is a past, present, future. Now I'm using the super system. as a resource, what I learned yesterday. Now, super system is a very good resource whereby in the future, many families will use their own 3D printer. So we just only sell the design to them. That means they just only print at home with the printer, because my wife always make noise that this one is always spoiled. If you are a mom, you're using this one, you know. So just change this one and then can be use it anytime, anywhere. So my darling won't disturb me anymore. Thank you very much. Darling, this one for you.
Thank you so much.
And also one for you as well. This is a rose. Okay. Thank you very much.
Okay, let's continue with the part 2. Okay, part 2 actually is a story which continues, where me, after 20 years later, I've grown up.
Yeah, after 20 years, my son has grown up. Just like his father, he's now a MyTRIZ master and he's helping people to solve problems. And this is the story. One day, my son met Mr. Carter, and Mr. Carter is a supervisor of a factory.
Okay, Mr. Carter, here is your mic. No, Mr. Carter, may I know why are you using your hand to cut the rubber? You're supposed to use your machine. It's much more safer and faster.
Oh, actually, I have an old machine, and this machine actually, when cut this car door trim, as shown in the figure. So the problem here is every time you cut, I have to change the cutter. The cutter lifespan is very short, so the production have to stop, and machine need to be reset again. I really cannot stand for it, so I better use hand and faster.
Okay. But what if I can help you to solve the problem? It will bring a lot of benefit to you.
Are you sure? So
Yes.
young, can you?
My father is a MyTRIZ master.
Oh, I see. All right.
Okay, let's see the benefit that you can get. First, the cutter lifespan is much more longer. You don't have to always change it. Means you don't have to always buy a new cutter, and it can reduce your cost. So, if the cutter don't have any problem, means your product also don't have any problem. Your quality of the cutter trim can be maintained as well as improved.
Okay, but I have a boundary condition for you.
Okay, let's
Sorry. So, the boundary condition is the cutter process cannot be changed. The cutter is made of metal. The conveyor belt is actually used in transporting the cutter trim. And then the cutter trim is made of PVC materials. But inside that, embedded with the steel frame.
Okay. Please give me some time to think of a solution first. Or MyTRIZ process flow. Okay.
Well, it's not a simple task, you see. So at home, my son is cracking his head, thinking how to solve the problem. First, he must think of a problem statement, then a suitable engineering system, followed by conducting function analysis and cause and effect analysis. In his head right now, he's thinking, should I use engineering contradiction? Should I use physical contradictions? Should I use substance field model? Or should I use trend of engineering system evolution? Ay, poor son. Just like his father, his hair is going to turn white very soon.
Okay, thank you, Mom. Okay, so first, Mr. Carter.
Yes.
Okay, do you mind explaining to me about your engineering system, your subsystem and your super system?
Okay, sure. For the engine system here, we have subsystem component and subsystem component. For the subsystem component, we have conveyor belt, car door trim, extrusion machines, controller, motor, cutter, and water. For the super system, we have a moisture.
I can't quite well imagine of your system. So do you mind explain to me your function as well?
Alright, so this is our machines. Okay, so now they have a controller, control the motor. The motor actually moves the conveyor belt, and the conveyor belt actually is a guide the car door trim, and then the water actually used to cool the cutter, and the water also cool the car door trim, and the cutter cut the car door trim, and the extrusion machine produce the car door trim.
I think you miss out on something.
Ah,
Maybe
really?
the water is not cool enough to cool down
Oh.
the cutter as well as car door trim. At the same time, because your cutter is made of metal, so the water might be harmful to your cutter and it will rust sooner or later. At
I
the same
see.
time, the car door trim also might be harmful to your cutter because it don't know when it might cut in the wrong position.
Okay. Alright.
So let's move on to the cause and effect chain analysis. What is the root cause? First, why is the cutter lifespan short? Is it because of the rubber material is hard? Is it because of corrosion happened? Or is it because of the cutter material is not good?
No. Actually, because of the cutter, they cut full frame of steel.
Oh, okay. So is it because of the cutter cannot detect where to cut, therefore it cut randomly?
Yes, I think it cannot detect where is the position to cut. The reason why they have these defects.
Okay. So let's move on to the cutter
Okay.
to the root cause.
Alright.
So as you can see here, the metal actually is embedded inside the rubber. This is the metal part. Okay. If the cutter cut at the red dotted position, which is the gap is considered safe, so the cutter lifespan is longer. But if the cutter cut at the blue dotted position with the full frame of steel is considered unsafe and the cutter lifespan is shorter. Okay, in order to solve this problem, please give me 1 day. 1 day. 1 day is enough. Okay?
1 day is okay, 1 year cannot.
Okay. 1 day I'll give you a solution.
Alright, so thank you very much. I see you a day after next. Okay.
So, at home, I have to figure out the engineering contradiction. What is the manipulating variable and the responding variable? Cutter cut randomly, not at the right position due to no guidance for the cutter. And the responding variable is more product will be produced, cutter wear faster. If cutter cut randomly, not at the right position, then the operator will produce more product, but the cutter wear faster. So, the improving parameter will be productivity, quantity of fasten, the worsening parameter is loss of fasten. Here we have engineering contradiction matrix. Okay, here is the selected embedding principle, but we are choosing part of it only. So the chosen one will be mechanical substitution, preliminary action, and feedback. So for the physical contradiction, okay, yeah. The manipulating variable is the position of the cutter, where the cutter should cut. The question is where the cutter should cut, the gap between the steel frame, and where the cutter should not cut is the full steel frame. So we are using the separation in space. The list of inventive principles are suggested: segmentation, taking out local quality, asymmetry, nested door, another dimension, intermediary and flexible shield, and thin film. So here, my mom will be coming out. My Mom, what are you doing?
I'm sewing your underwear.
Please don't do that.
Mom loves you, son. Look at your underwear. The hole is so big. Why do you shy, Gary? Ouch! I put my hand in the needle.
Mom, are you alright?
Don't worry about Mom.
You should be more careful. You should know where is the gap. You have been sewing my underwear for many years.
I have plaster to seal the wound. But then, look at the hand. I have so many needle wounds.
Oh,
Well, can you are the MyTRIZ master? Can you help me to solve the problem so that the needle won't poke my hand?
Sure. Can I have a look of your needle? Oh. So, can I use the needle as an intermediary for my solution? Let's take a look at the subfield model. Okay. If my needle is poked at the harmful zone, poked at the full steel frame, is considered a harmful zone. But if my needle poked at the gap, is considered a useful zone. So here, I can use a measurement and detection class 4. And the solution that I choose is 4.2.1. You can refer to TRIZ book actually. Okay. So next, it will be, in order to make it more complete, how did I send a feedback to the system? It will be using a trend of engineering system evolution, the trend of increasing completeness of system components, such as function of operating agent, transmission, energy system, and control system. So, 1 day later, I meet Mr. Carter, and here is my proposed solution.
Oh, really?
And here is the first solution, mechanical substitution.
Okay.
So this is a machine that I got it from YouTube. It can cut whether it's metal or gap, it doesn't care. It won't hurt the machine or the product at all.
So you don't need to identify where is to cut, just cut, then cut already.
Yes.
Oh, I think it's very expensive one. I don't want this. I want cheap one you have.
Cheap one, okay.
Yeah.
Let's look at the second solution. It's using a feedback system. It's a sensor. This idea is come from a bicycle belt chain manufacturing system. It's using the sensor to detect where to cut.
Oh, it's laser. Sure, expensive one. Cheap one. I want cheap one. I don't want this.
Alright.
Alright.
Yeah. Okay, let's look at the intermediary. Intermediary
like
is
Sewing?
sewing. My mom, I get it from my mom.
Oh.
When my mom is sewing, I know it.
Alright.
So it can detect where is the gap. Because once when you're sewing, if you accidentally put your hand, you get feedback and you know it's hurt.
Oh, needle ah.
Yeah.
Oh, okay, I think should be okay. As long as the cost is low, then it's alright. Okay. So good idea. Let me go back to implement it. Alright. Thank you very much for your proposed idea. I go back to implement it. I will let you know after 1 week.
Just give me a call.
Alright. Oh, thanks.
So 1 week later, here is the final solution. A needle sensor is implemented, and it's faster, better, and cheaper. By using MyTRIZ, it provides that the MyTRIZ tool can be successfully applied to solve above industry problem. Let's just look at the video. So this is the video which is currently implemented at the company that we are trying to solve the problem. It's using a needle. Here is the needle. Let's look. Okay. Yeah, here's the needle. It will try to poke several times to detect whether it's gap or the full steel frame. Once it's confirmed, then it cut.
Oh, thank you very much. Actually, I've implemented it. Thank you.
Thank you.
Thank you, MyTRIZ Masters. Okay, actually, I have many projects in my factory. Can you help me to do again?
Yes. I'm very grateful that you have given me a lot of projects to do.
Well,
Alright.
my son has helped Mr. Carter to solve his problem, and Mr. Carter gave him a lot of projects and other projects. Thanks to MyTRIZ.
Thank you very much.
Thank you very much for excellent presentation. So you might be thinking about opening some theater of MyTRIZ. MyTRIZ Kennedy or something like that. To make story short, I actually liked those problems, and they were explained quite well and quite nice. One small question to the first problem is, again, like to the previous team, I was looking at your presentation of function model. Can you open, please? Because I want to make this comment because I see it the second time. Functional model. No, not easy. All right, but it doesn't matter. In this functional model, which you showed on the screen, was an interaction between the bottle and the dirt excessive. Right? But here, in the book, it's different.
All right.
It is correct here in the book.
Yes, maybe
Because,
you did change it. All right.
Actually, this is just to let everybody know.
Yeah.
When you say excessive, excessive is always a positive function.
All
Right? It just delivered with too much use of resources.
Okay.
So it creates waste.
All right. Okay.
Well, I know it very well because these tags, excessive, insufficient, poorly controllable, to function analysis, they were introduced by me back in 1991. So
Thank you very much for your
you can
comment.
speak to me about it. So when you put something as excessive, you mean that function must be there. It just must be optimized. And harmful function is something that you don't want at all. There is no direct, you don't want it. See? That's for the rest.
Thank you very much for your comment.
All right, welcome. So also the second command was you use a kind of a lever to open that part. But you have a resource, you have a bottle. So when it reaches the end of the bottle, you can use this force, for example, pressure, whatever, to turn the part as you need, right? So in this way, you can make it cheaper and probably adaptable to different types of bottles. Again, the rest, excellent. I like it very much.
Thank you very much.
Thank you.
I really enjoy it. Thank you very much.
Thank you.
Yeah, I asked Dr. Ye that how many rehearsals today have it, but he did not answer.
You mean how many years?
How many?
How many
rehearsal.
times have you taken the rehearsal for your performance?
Actually, we worked hard on the past few weeks. Actually,
Well,
yeah.
many times.
Yeah,
How many times? How much
how many
time did you
times?
spend to make such a great performance?
2 weeks non-stop.
Oh
Yeah,
yeah.
yes.
I'm sure.
But yesterday, still working, but it's not performing well. When you look at all of you, then you have to do something. You know? Yeah.
I love the heroine. And did you file your idea as a patent?
You mean the first one?
Yeah,
no,
first
we
one.
still haven't patented.
Oh, I
Yeah.
recommend you to
Yeah.
discover the patent database
Alright.
that the same things are already patented or not.
Yeah.
Yeah. Okay. So there is no additional question for you. Just really, I enjoy that. I will copy your performance here.
Thank you.
I
Thank you very much. Thank you.
It's a spread. I distributed your performance to Korean people. Okay?
Okay,
If
no
you allow
problem. No
me.
problem.
Okay, thank you
I
so
haven't
much.
patented.
Any more problem? Question?
For the first one, this direct building with generate idea is the one contradiction you can generate many solutions, and now you still use mechanical. So next one you may use less time for this. This is not prepared for, but
Oh, okay.
I give you.
Oh, okay.
But before you get that, just tell me how to work for this one. How it works. Yeah.
It's separation.
No, sorry. Just to tell you about. If you give me right answer, I give you.
How many chances we have?
Sorry. This is low cost one, so.
No, how many chances?
Mechanical substitutions, taking out.
No, this is just a spare part. What is inside this? Yes. Some. Yeah, you don't remember about mechanic, acoustic, chemical, thermal? I don't know. Maybe thorough, maybe electric. Anyway, I give you. So the solution maybe not belong to just only one field, maybe any field. And then the part two is beware for the secondary problem, because you still use mechanics. If you use the magnetic, you will get another solution.
Thank you very much.
We use the needle solution because the boss inside the factory is really
Stingy.
stingy. That's why you only can
So
serve
they have
the
the low
low
cost.
for them. Okay, thank you.
Thank you very much.
Yeah, maybe just one comment. Yeah, I think the way of presentation is very unique. So I commend you on your very interesting presentation. So I would like to also commend you on the faster, better, cheaper. So I think it's good because industries always look for the fastest and the best and the cheapest solution, right? So I think your solution fits what the customer is looking for. So okay, very good. Thanks. Thank you very much.
Congratulations to Team 9 for your very enjoyable presentation.